Nicolas Perez from Del Mar College in Texas. How you doing, Nicolas?
Good, good.
So you were another one of the national laboratory people, right? This summer?
Yes, sir.
Yeah, and which laboratory did you work at?
I worked at Texas A&M Corpus Christi under Kirk Camerata.
And what kind of work did you do?
I did work with stress-related genes in seagrass. Okay, so.
Could you tell us a little bit about what that work was? What do you mean by stress-related genes? I got a lot of stress. Are you talking about my kind of stress?
Maybe, might be something like that. This whole research started because we were noticing a global decline in seagrass across the world. And that's a big deal because seagrass is a keynote species, so the economy kind of hinges on that one species. If it goes down, the whole ecosystem crashes.
Yeah.
Okay, so and of course we depend on a lot of the compounds that these plants make, and a lot of the compounds that the algae that live in the plants make, you know, for all the various products that we have. Well, right now, all we can really do to assess the health of seagrasses is to go out and take biomass-related tests, which is they just take the seagrass and they measure how much of it is dead or alive. You know, we really don't have any way of knowing what stressed it out to lead it to die. Well, that's where these stress-related genes come in. These are genes that are in the biochemistry of these organisms that are turned on during times of stress. Okay, so let's say the seagrass is being stressed by high salinity, high salt in the water. Then a certain stress-related gene will be turned on, and it'll start to express itself in the creature, and they can make different proteins to combat that specific stress. Well, what we were trying to do was sequence those genes. And once we know the sequence, okay, at least the way I understand it, once we know the sequence, we can test seagrass in the wild, look at its genetic sequence, look for that gene, and see whether it's turned on or off. Well, depending on which genes are turned on, that would correspond with a specific stress in the environment. So we would at least be able to lean in the direction of what was stressing it out, so that we could work to, you know, to fix the problem, whether it's anthropogenic pollution or just something natural like high salinity or high temperature, things like that.
That's great. Well, that's great. That's a great explanation too. Very good.
Oh, thank you.
So, are you gonna go back next summer? I know Brendan is, I believe.
I would love to go back. They said that I could come back anytime I want to, so I'm gonna hold them to that promise.
That's
so
great.
I'd love to see where the research goes. Very small slice of the pie here. Months of research done before this, and still months of research yet to be done. So.
Excellent. And I know you got an award this morning, so congratulations on that.
Thank you.
And is this the first time you've been to DC?
That's right, first time.
What a great opportunity, huh,
right.
for a
Very
community college
city.
student.
Beautiful city.
Excellent.
So.
Well, congratulations and thank you.
Thank you.